In this video, I'm going to solve a numerical problem on Stoke's theorem. This slide contains the problem. The magnetic field intensity H is given. A rectangular path is defined. If you have to verify the Stoke's theorem for the given magnetic field, the problem is copied here. Let us go through it. Evaluate both the sides of Stoke's theorem. So let us write the Stoke's theorem. That is line integral of H over a closed path is equal to surface integral of curl of H. So this is what the Stoke's theorem in terms of the vector H. And the rectangular path around the region. So we have to choose a rectangular path around which the vector H has to be evaluated. Let us see what information is given. So the rectangular path is defined by X variable and Y variable. So we can take one direction as X, another as Y. X varies from 2 to pi. X is increasing from left to the right. So lowest limit is leftmost side and the highest is to the rightmost side, 2 to 5. Similarly, for Y is growing upward. So the least one downward, up. That means this topmost side of the rectangle on which Y is 1, here Y is -1. Similarly, on the right side, X value is fixed as 5, here X value is 2. And the entire rectangular plane, Z value remains 0, it's constant. The rectangular plane is actually perpendicular to Z axis. If you want to show that, the plane is like this, perpendicular to Z axis and meeting Z axis at 0. So it is Z is equal to 0 plane. The positive direction of ds. So a differential surface is given here, ds. That is an increment differential area on this rectangular so ds is a differential area on the surface enclosed by this rectangular path, and the direction of ds is given as positive z direction, positive z. That is why the differential area is dx into dy. So the information is copied here. Let us go for the Stoke's theorem, that is line integral of h on the path. So path on the path h has to be evaluated. Let us choose the direction of evolution for the path, evaluation for the path. Consider the left-hand side of the Stoke's theorem, that is closed loop integral of h. This closed loop integral, I would like to split it into four paths which are different in directions. Let us take this as A to B, then B to C, C to D, and D to A. Then One integral is to be taken on a to b h dot dl. Second one b to c, c to d, and d to a. The closed path is separated as separate integrals. Now we shall evaluate one by one here. We shall decide what is the differential in the dl for each path. Let us say, if I take for a to b h dot, dl is the differential length on this path in this direction. Since this path is parallel to x-axis, this is going to be dx. And the arrow is oriented in positive x direction, that is why it is a cap x. So dx a cap x. Similarly, for path b to c, h dot, the differential length, b to c, it's here. This is the path. This is parallel to y-axis. So it is dy. This arrow of the path, direction of the path is aligned with positive y direction. So ay, dy, ay. From c to d, that is yes, c to d, this path is the dl, and this is parallel to x-axis. Horizontal line dx. See, this arrow is opposite to positive x-axis. That's why it's going to be minus ax cap. So h dot minus dx ax. The last path is d to a. This one. This is parallel to y-axis, so it is dy opposite to positive y direction, so minus ay. H dot minus dy ay. So we have evaluated dl over each path. Next, we shall decide the h value in each integral. H can have any component x, y, or z. Since the dl has only x component, so here it can also have x component. So within the h, if x component is present, then ax cap dot ax cap is 1. If any y component is present, ay dot ax is 0. Similarly, az dot ax is 0. So y and z components are converted to 0 because of the dot product. Only x component is considered. So unit vectors dot product between the unit vectors is 1. So what is left is only x component of the h into dx. Similarly here, same way, y component into dy. This is for b to c, and this is here x dx minus hy dy for d to a, c to d. Now we have to substitute for hx and hy from the problem. If you look at the problem, yes, here 6xy is the coefficient of a cap x, so this is hx, and minus 3y square is hy. So from a to b, hx is 6xy dx plus hy is minus 3y square dy minus 6xy dx minus 3y square dy. This is path d to a, c to d, b to c. In the first integral, integration is with respect to x. So 6 is constant. See, y is also constant. If y is constant, then what is the value of y from a to b? From a to b, y value is minus 1. Similarly, from c to d, y value is plus 1. Y value is plus 1. So if you just recall this rectangle here, this is x-axis and this is y-axis. Y is minus 1 to plus 1. This entire line is y is equal to minus 1. That is a to b, y value is minus 1. Take it out, y value minus 1. Then integration is only required for x dx from a to b. Similarly here, minus 3 is common. What is to be integrated is only y, b to c. Minus 6 here. As I said once again, y is constant because integration is with respect to x. From c to d, this is c to d. On this y value is 1. So y is 1, becomes constant, goes outside. C to d is x dx. The last path is minus to minus plus 3 y square dy dta. So everything is ready. We can have the limits accordingly and integrate each one separately. So our LHS then becomes minus 6. Directly we'll go for integration. Integration of x is x square by 2. Limits for x is 2 to 5. Minus 3. Integration of y square is y cube by 3. Limits for y is given as minus 1 to plus 1. And this is minus 6. Integration of x is x square by 2 from 2 to 5 plus 3 is y cube by 3. That is from minus 1 to plus 1. Here 2 can be taken out here. So that is 5 square minus 2 square. 3 cancelled, minus 1 cube is 1 minus 1 cube. That is cube for both of them. Here also 2 comes outside. 5 square minus 2 square. Again 3 cancelled. 1 cube minus 1 cube. So the final simplification gives us this is minus 3. 25 minus 4 is 21. This is minus 2. Again minus 3. 21 plus 2 minus 2 cancelled out. Finally, we're going to get minus 63 minus 63 minus 126. That is equal to amperes. This forms the answer for left-hand side of the Stoke's theorem. Let us go for RHS of the Stoke's theorem. Remember the answer. On the RHS, it is surface integral of curl H. Open surface integral of the curl H. So let us calculate curl H first. The problem is given in rectangular coordinate system. So curl H can easily be found from the determinant. Dou by dou x, dou by dou y, dou by dou z, hx, hy, hz. So the determinant helps us to evaluate the cross product easily. Curl H. Let us substitute the values. Partial derivatives. Hx in the problem is 6xy. Hy is minus 3y square. Hz is 0. That component is not there in the numerical problem. So we have to find the value of the determinant. So that is ax. Ax means we have to take these two multiplications. Dou by dou y of 0 is 0. Dou by dou z of minus 3y square. Next middle one, ay cap. In this case, ay cap means it is the product of these two. So dou by dou x of 0 means 0 minus dou by dou z of 6xy. Now the last one is plus unit vector of z axis. For that, it is product of these two terms and the difference of those two products. Dou by dou x of minus 3y square minus dou by dou y of 6xy. Finally, the curl of h is given by 0. Differentiation with z, no z, 0. Differentiation with z, no z, 0. Differentiation with x is also not there. Only one term exists here, that is minus. Differentiation of y is 1, so minus 6y into a cap z. This is going to be the curl. After getting curl, the right hand side of the Stoke's theorem is surface integral of curl h dot ds. So in this step, curl h is minus 6x az cap dot ds. So in the numerical itself, it's given that the ds is oriented in positive z direction. So the direction is z cap. Then the two sides are defined by dx into dy. So the area, differential area within the closed path is dx into dy along with az. So now az dot az is 1 minus 6x dx dy. The surface integration minus x common. X is integrated, then multiplied with the integration of y. Y limits minus 1 to plus 1. X limits 2 to 5 in the problem. Equal to minus x square by 2 after integration 2 to 5. Integration of dy is y minus 1 to plus 1. minus 6. 5 square by 2, 2 square by 2, y is 1 minus of minus 1. Minus 6. Take 2 with this one. This is going to be 21. This is 2. 2 cancelled here. Minus 126 amps. We got the same answer on both the sides. So that is why the left hand side evaluation when compared with right hand side, both are equal. We got 126 for both of them. Hence the theorem is verified. So the given vector satisfies the Stoke's theorem.